All right, I've got one last problem here that I'd like you guys to try, and I might throw this on a homework or on a quiz or a test summative at some point, just because I think it's kind of a fun problem. But we have an arch here, and I think this is taken from a problem where this was used in the construction of a bridge, this type of design. But it's made up of a bunch of isosceles trapezoids. In this case, we have 9 isosceles trapezoids. Find the measures of the angles in each trapezoid. So we're not given any numerical information other than there are 9 trapezoids, which is an important piece of information. Since it is isosceles, it says made up of nice isosceles trapezoids. They are indeed nice, and all trapezoids are nice. But I think what we mean here is that there are 9. I even read that the first time and didn't see that typo. But there you go, 9 nice isosceles trapezoids. All right, so if we look at this, really, there's a couple ways of doing it. One is to use that formula from earlier in the unit. Another way is to think about it completely differently. But basically, we have half of a polygon here. If we look at the outside and we continue to trace this all the way around, really what we have is half of an 18-sided polygon, because we've got 9 sides here, and then if we continued another 9 sides here, we would finish up the polygon, and so we would have 18 sides. So each one of these angles in here is like one of the angles of that particular polygon, each one of these for that matter as well. So if we knew the entire angle sum, we could divide it by 18, and we'd have each one of those angles. Well, let's try that first. So we have an 18-sided polygon. 180 times n minus 2 is our angle sum formula. So 180 times 18 minus 2 is the same thing as 180 times 16, which is 2,880 degrees. So that would be the entire angle sum if we continued this 18-sided polygon all the way around, or completed the 18-side polygon. And so each one of these would be one of the angles in that polygon. So if we're going to find each one of those angles, let's go ahead and divide that by 18, and then each angle would end up being 160 degrees. So each one of these angles in here is 160 degrees. All right, and you could continue that all the way around, and each one of these, for that matter, is 160 as well. Now, the trapezoid itself, though, is not a 160-degree angle right here. It's actually, since there's our isosceles trapezoids, we know all these angles are exactly the same across the same base. So if we divide that by 2, we get each of the angles to be 80 and 80s, because 80 and 80 would make that 160. So 80 and 80 here, and so on and so forth. So we know that angle is 80, and that angle is 80, and that angle is 80, and so on and so forth. And then, since it's a trapezoid, we know consecutive angles between the bases are supplementary. So 180 minus 80 would leave us with 100. So each one of the angles of the trapezoid will be 80 degrees for 2 of the bases and 100 degrees for the other base angles. So one set is 80 degrees, one set is 100 degrees. So that's one way to do it. Another way to do it is to think about this and listen a little bit differently. Oh, we've got the spinning pinwheel here. Okay, good. Think about it more like a 180-degree angle here, kind of like the straight angle that's being divided up into 9 different parts. So basically, we could make each one of these isosceles triangles if we just extend all the way to the center here, and you'll notice that where they all meet right here is basically a 180-degree angle, because it's a straight line. So you talked about like a linear pair of angles. This is like a linear group of 9. So if we think of that 180 degrees right here, and then divide it by 9, then each one of those angles right there would be 20 degrees. So each one of these will be 20, 20, 20. All these will be 20, all the way around, 20, 20, 20. Okay, so all those are 20. Now let's think about the isosceles triangle here. So if we know we have 20 degrees for this angle right here, and we think about the triangle itself, then the remaining 2 angles would have to be equal to a sum of 180 minus 20, in other words, 160 degrees, and 160 divided into two equal parts would be 80 and 80. So 80, 80, and 20 would make the angle sum of 180 degrees for that triangle. So that's another way of doing the calculation.